Now let's continue. Right. Today we'll see some important concepts about the friction. Listen carefully. So take this problem. Hmm. Find the value of acceleration and friction, frictional force. Here is a uh, they apply the different type of forces. They apply different forces. Each case we need to find the acceleration and the how much will be the frictional force. No, exact values. So then only we'll understand. Actual to understand only I set it the values like that. Mu s is 0.4, mu k is 0.3. Mu s means coefficient of static friction. Mu k means coefficient of kinetic friction. Okay, listen carefully. Listen first. So basically, generally, whenever the mu k separately given, so you have to be very careful. So if in the some problem they will give only one value they will give. Either simply they will give us mu they will give. Coefficient of friction equal to something they will give. Okay, then so that is mu k both will be taken as equal will consider. But practically those values are never be equal. When these two values are given separately, you have to be very careful. And first of all, what we need to do here, we need to find out the limiting friction we need to find. What we need to find? Limiting friction. Limiting friction, that is a maximum value of static friction, is called as the limiting friction. Maximum value of static friction is called as a limiting friction. So look at now here. So limiting friction we need to find here first. Limiting friction formula. Yes, the limiting friction formula, which is given as FL, which is equal to, that is mu s into n. Remember, mu s into n. Mu s is the static friction. N is a normal reaction. N is a normal reaction. We need to find from the block figure. Look at now here. So here is a block now. Now look at now here. Weight of this block is vertically downward direction. How much is weight? mg. That is 100 newtons. 100 newtons is downward direction. Now this block will cause certain amount of force on the floor. How much force will cause? 100 newtons. This body is there, it will cause 100 newtons. At the same time, this board will also offer a certain amount of force on this block. Which direction? Upward direction. That is called as a normal reaction. So this means here, this is how much this force you tell me now? This is a, and this is the normal reaction. And look at now. Here we have placed the body here like this now. Is the body moving up or down? That means what tell me now? Upward force equal to downward force balance. So that means what I can write now here? Yes, n is equal to 100. This step clear now first of all? 100 newtons. Right. Now we'll find the, what we'll need to find now? Limiting friction we need to find. So how much the limiting friction? That is FL, which is equal to mu s, not mu k, mu s. Limiting friction only contain mu s only. How much the nearest value? 0.4 into n value how much? 100. So that means how much will come this value? Tell me now. How much this value will come? Applied force. So here frictional force will denote the small f generally. So from this, what I can say now, limiting friction, which is equal to how much we can say, tell me now? 40 newtons. This point clear now? So always do remember whenever they given a MUS is given, keep in mind first step, you need to find the limiting friction you have to find. That is MUS into N. First step clear? Now listen carefully. Here we are going to see different cases we are going to see now. So applied force. And we apply the force like this we apply. If the body want to move, the body has to move right side or left side? Right side. So this means body has to move, the right side has to move. If the body tries to move right side, there is a friction will develop in the opposite to the motion of a body. So since the body tries to move the right side and the frictional force is what direction now? Left side. This is the frictional. Right. Now look at now. Now here this normal reaction we got will place here. Now let's see in this case now we apply the forces we applied. Different forces we applied. Let us say first case. How much the force we applied, you tell me now? How much the force we applied now? 10 newtons we applied. We applied the 10 newtons of force we applied. Now you tell me now what will happen now. So 10 newtons of force we applied the right side. And how much the frictional force? Friction is how much? Limiting friction which I calculated how much the limiting friction? 40 newtons. Is a friction. Yeah, limiting friction only, friction only. Okay. So how much the limiting friction you tell me now? 40 newtons. Now you tell me now here. We applied at 10 newtons we applied, but 40 newtons is their friction. Now will the body will be move or not? I'll just understand. Look at now here. So just imagine now this block. We apply the force of 10 newtons we applied. And friction between them is how much? 40 newtons. Now apply the 10 newtons is applied. Will the body will move? Will the body move backside? Will the body move backside? And front side will move? It does not move now. Try to understand. Will the body will move or not? Then what the acceleration of a body? Acceleration of a body is how much you tell me now here? 0. How the body you tell me now? At rest. So here the body is at rest now. So that means if the body is at rest, then how much what type of friction it will contain?
Well, if the body should be at rest, means both the forces should be balanced forces.
Listen. So here, so listen. So acceleration is 0. Body is at rest or not? So you tell me now here. That's what I'm telling here. Here is the actual concept of friction. You'll understand here. We applied 10 newtons of force. We applied on this body, and 40 newtons is the friction. Now you tell me now what happened to body? What happened to body? It is lively visible to you now. Is the body is moving? No, it is not moving. If forward or backward is also not moving. So that means the body is at rest. First, this is clear. And body acceleration of the body is how much? 0. Here is if the body is at rest, what type of friction will call that as a static friction? So that means here this is what type of friction here? Static friction. Now you tell me now here. Static friction. Then how much will be the frictional force? Now your point will come into picture now here. So if the body is at rest means what tell me now? So the left force must be equal to right force. Now in this case now, so here this is a limiting friction, that is what tell me now? Maximum opposing force. we applied 10 newtons is applied, but still the body is at rest only now. Now, if the body is at rest means left force must be equal to right force. Now the frictional force is how much now? 10 newtons. This is what in the 40 is a maximum force. Try to understand it. That's what I'm saying. 40 is the maximum frictional force, maximum opposition we have. So now, as you told me now, so here we applied 10 newtons, but the body is not moving. That means if the body is not moving, as we know now, according to Newton's law, acceleration equal net force by total mass. Acceleration is zero. That means what? A net force must be zero. That means friction must be adjusted to the applied force. That's what we used to call the static friction. Static friction is what type of friction is a self-adjusting force. I told you. Static friction is what type of force is a self-adjusting force. Now here this is the start. If the body is at rest, in that case, what happens now? Frictional force is how much you tell me now here? Frictional force which is equal to applied force. Frictional force equal to applied force. How much the force we applied? 10 newtons applied. That's why frictional force is how much now? 10. Understood what I'm saying? Right. That's what we have seen yesterday. We have seen the diagram. We have seen. Look at now. Look at now here. In this diagram, you need to understand now here. So here, so you apply the, so up to here, up to point here, body is at rest only. Now here, we apply the force now, let us say 0 newtons is applied. That means how the body, up to point A, from here 0 to D, body is at rest only. So when you apply 0 newtons, is the body will move? No, then how much the frictional force? If the body not moving, friction is equal to applied force. That means frictional force equal to applied force. That's why this is 0, 0 coordinates. Now let us say we apply the 10 newtons applied. Let us say here 1 newtons we apply. Let us consider. This is 1 newton applied. Will the body will move? So up to here body is not moving, yeah. Not move. If the body is not moving, how much the frictional force? 1 newton. So that's why here friction equal to 1. So that's why here if you see coordinates 1, 1. Next, if we see this thing, let us say 5 newtons you applied. Is the body is moving? Still it is not moving. That means what? Tell me how much the frictional force? 5 newtons only. So this is the 5 newtons. Okay, that's why the graph you will got it is in a straight line. How we got the point in the graph is straight line? You see this thing? These are the form y is equal to mx graph now. Y equal to mx graph should be what? Tell me if you have the points 1, 1. Yes, 2, 2. 3, 3. Like this we have the straight line will come or not? That's why the graph. X coordinate 1 aitho, y coordinate also 1. X coordinate 10 aitho, y coordinate also 10 only. Then only straight line like this will come. Isn't it? Slope is equal to mu. Understood? So that's what we wrote now here. This point clear? Yes. Now for the 10 newtons we have observed. Now let us see what is the next force we applied. Now you do analyze for 20 newtons now. Now we are applying the force. Applied force is how much now? 20 newtons. Now you tell me, if we apply 20 newtons, what will happen? 20 newtons of force we applied. Now you tell me what will happen. Tell me now how much the limiting friction? Limiting friction fixed value of a fixed problem, fixed only. So how much the limiting friction? Limiting friction which is a 40 newtons. Okay. Limiting friction 40 newtons. Now you tell me now how the situation of a body. Body is at rest or motion? Rest. So that means what? Tell me now. If the body is at rest, what type of friction? So that means what type of friction is a static friction? So then how much, whatever the acceleration you tell me now? 0. Then how much the frictional force? Now in this case, frictional force which will be equal to 20 Newton. Frictional force equal to applied force only na. Why? Because body is at rest. Understood? Now see the next force now we applied. 35 we applied. Tell me now. Next we applied 35 Newtons के लिए बोलिए. We applied the force of 35 Newtons. Yeah, you tell me for 35 Newtons. Yes. How much the limiting friction? Limiting friction 40 Newtons we calculated. Now here applied force is less than the limiting friction na? So here this applied force is less than the limiting friction, right? Then how the body is now? The body is at rest. If the body is at rest, that means what type of friction? Static friction. Static friction. So how much the acceleration? Tell me now. So this is acceleration is 0. Then how much the frictional force? 35, 30 by 30. And frictional force is how much now? 35 Newtons. Right. Next one. Next one. 9.99. So that's why you have taken the values like to have it. And limiting friction we have 40 na. That's why only we have taken 39.99. What will happen? Tell me now please. So here, so how much the applied force now here in this case? 39.99 Newtons. Tell me how much the limiting friction? Yeah, limiting friction 40. Will the body will move or not? So here the applied force is less than the limiting friction. Limiting friction. So that's why body is at rest only. If the body is at rest, what type of friction? Static friction. Static friction. Then acceleration how much? 0. Then how much the frictional force now here? 39.99. अभी ये बात समझ में आया? Got this point now? Right. Now, what the next one we applied? How much the force we applied? 40.01. Now tell me now here, in this case, tell me what will happen. When we apply the applied force, how much this value? 40.01 Newtons we applied. Then, how much the limiting friction? Limiting friction 40 Newtons. Now you tell me now here, applied force is more than the limiting friction. Then what happens? So applied force is more than the limiting friction. So body is in motion. If the body is moving, what type of friction it has? Kinetic friction now, remember. If the body is in motion, it is a kinetic friction. So that kinetic friction we need to calculate now. How much the kinetic friction formula? That is mu k into n. So that why Fk is equal to mu k value how much? 0.3. N value how much? 100. That means how much the kinetic friction now? 30 Newtons. Now the body is in motion now. The body is in motion. What type of friction it has? No, then there is no limiting friction now. Now frictional force is kinetic friction now. So now in this case, what type of friction here it is? This is the kinetic friction. This is kinetic friction. Now we need to find the acceleration. Now, how much the frictional force now here? Kinetic friction. How much the frictional force is now? 30 newtons. How much the kind of friction force now here? 30 newtons. Now you tell me now this block is like this now? Yes, block. Yes, so this is now here in this direction we apply the force. How much the force we applied? 40.01 newtons we applied. The friction is like this direction now. And what type of friction now here? Kinetic friction. So the body will move like this direction now. Then what the acceleration of the body now? Yes, that is so in this case, yeah, so that is nothing but what applied force minus what tell me now Fk by mass of the body. So that is A is equal to what tell me now this is 40.01 minus Fk value how much now 30 by mass of the body how much now 10. So you can see now how much this value. This is 10.01 by 10. So which will be equal to 1.001 meter per second square. Hmm. Right. Yeah, you see the things now here, just understand. Previously, when you applied 39.9999 like this, we applied. Body is at rest. How much the frictional force? In that case, when you apply the 39.99, how much the frictional force is there? 39. Acceleration 0. Frictional force is there, na? Now in this case, you tell me now here. So when you apply the 40.001, very small value, then see the how much the difference is there. Okay, that's what you need to understand here. Right. So whenever they given mu s compulsory, we need to check this thing. Mu s given means you have to check this thing. Mu s not given, it is well and good actually. Now you tell me now here next one, how the next force we applied? 50 newtons. Now you do for 50 newtons now. Now do for 50 newtons also. When we apply the force, that is F is equal to 50 newtons we applied. So how much the limiting friction? Limiting friction. Do it. Limiting friction. How much here? 40 newtons. Now here the limiting friction. So applied force is more than the limiting friction. Then that means what happened to the body? Applied force is more than the limiting friction. So the body is moving. If the body is moving, what type of friction it will contain? Kinetic friction. Now we need to find the kinetic friction now. Find the kinetic friction. So that is kinetic friction Fk equal to what? Tell me how much this value? 30 newtons na? Fk is equal to mu k into n. Then, so we need to find the acceleration of the body now. So this is 10 kg. Now we apply the force we applied. How much the force we applied is that is 50 newtons, and we have a frictional force that is Fk. So then this direction the body will move now. So the acceleration of this body, which is equal to how much now? 50 minus 30 by 10. So that is how much this acceleration? Yes, 2 meter per second square. Right. Then, like this we should do. Chalo. Yeah. Now take the next problem. Yeah, do it. Take the diagrams you want to take now. The data you take. Hmm. Right. So first we need to find a normal reaction. Limiting friction case, we have to find the normal reaction. Why? Because mu s is given now. So first we need to find the normal reaction we have to find. Right. Find out the normal reaction first. F is there now. Whenever mu s is present means we have to do the limiting friction first of all. Right. And see the block now here. And here how the force we applied. Yeah. Whenever some angle is there, we have to resolve it. So here this is the force we applied. This is the F. Now resolve it. And here this angle. How much this angle is? 37 degrees. Now resolve into components. Do it. Right. So this component 4 by 5. That is F cos 37. And this upward direction we have. How much this is? F sine 37. And weight of this block is downward direction mg. So that is equal to 100 newtons now. Next, normal reaction, upward direction. Now, since the body does not move up or down, so upward force equal to downward force. Now, tell me now here what are the upward forces? Yes, that is F plus N plus F sine 37 equal to how much now? 100. So from this we can get the N value which is equal to how much now here? 100 minus F sine 37. Okay, this is a normal reaction. Now, so here the two cases they has given in this case. First bit they given F value 10 given. Okay, so now here first bit. They given F value, how much given now? 10 newtons is given now. From this we can get the N value. Tell me now. How much is N value? That is what? Tell me now. 100 minus F is equal to 10 into sine 37 value 3 by 5. So will come to be how much the N value? Tell me. Which is equal to 5 twos now here. 6. That means 96. Sorry, 94 na. 100 minus 6, which we have this as a 94 Newton. This is what you tell me now? Normal reaction. We need to find the limiting friction in this case. Completed. And what's the limiting friction now? Limiting friction, which is equal to mu s into n. So that is how much the mu s value? 0.3 into n value, that is 94. Then how much will come this limiting friction? Tell me now. How much this value? This is 12. So 27 plus 1. Yes, that is 28.2 newtons now. This is the limiting friction, right? Yeah. Now look at now here. Now here, listen. If the body can move, which direction the body will move here? Right side. So which force makes the body to move right side? Only F cos theta only makes the body to move right side. That is only applied force, not F. Remember, even though we applied F, we applied. So only F cos theta only will make the body to move, isn't it? So that's why that is only the applied force now here. So how much the applied force, you tell me? So in this case, applied force, how much? How much the applied force now? That means F cos 37. F value how much? 10. 10 into cos 37 value 4 by 5. That means how much this value? 8 newtons. Applied force is 8 newtons and limiting friction is how much? So that means here, will the body is motion or at rest? Yes, how much the frictional force is how much? Yeah. Though this is the frictional force, you apply this much of the force now, will the body will move? So here the applied force, in this case, what happens? You tell me now here. Applied force is less than the limiting friction. Applied force is less than the limiting friction. Na? So that's why how the body, you tell me now. The body is at rest. If the body is at rest, then what the frictional force, you tell me now? What type of friction will contain? Static friction. Then how much the frictional force, you tell me now? That is nothing but, if the body is at rest, what is the frictional force? Frictional force equal to applied force. If the body is at rest, frictional force equal to what? Tell me. Applied force. Applied force. So that means how much the frictional force in this case, you tell me now? 8 newtons. Got it? Done. Now this is the first case. Here we apply the F value. How much in this case we did now here 10 newtons case. Now you do for 50 newtons. Now do for 50 newtons case. Now here normal reaction same equation now. This is the normal reaction equation we have. How much? N is equal to so in this case, second case, how much the F value applied? 50 newtons is applied. So that means normal reaction is how much now? 100 minus F sin or cos? Sin 37. So that means N value we can get now. This is 100 minus what are now 50 into sin 37 value 3 by 5. So the N value will come to be how much now? 100 minus 30. So we got this N value how much now? 70 newtons. Then in this case, limiting friction is how much? Yes, limiting friction is how much now? This is mu s into N, and mu s value how much? 0.3 into N value how much? 70. So this value will come to be a 21 newtons. And this is limiting friction. Right. Now you see this thing here. How much the applied force now? How much the applied force? Applied force is how much? Here, which force makes the body to move? Which force that makes the body to move now? Which direction the body will move here? Right side. Which force will cause us? F cos theta. So that is what the applied force now here. So that is F cos 37. So how much is F value? 50 into, tell me now here, this is 4 by 5 na? How much is value? How much is applied force now here? 40 newtons. Yes, applied. We got the applied force 40 newtons. How much the limiting friction? Tell me. How much the limiting friction? 21. Applied force. That means applied force is greater than the limiting friction now. So means what happens? You tell me now. Body is in motion. Applied force is greater than the limiting friction. So body is in motion. Then what type of friction it will contain? Kinetic friction. So that kinetic friction we need to find now. Fk is equal to what? Tell me now. That is mu k into n. How much the mu k value? 0.2. N value how much? That is 70. So that means how much the Fk value? Yes, 40 newtons, right? Okay, now body is in motion means we can find the acceleration. So tell me the acceleration of the body. This body which will move, applied force is how much now? How much the applied force is? 40 newtons, na? How much the applied force? 40 newtons. And the frictional force is how much? What type of friction? What type of friction it will contain? Kinetic friction. And the body will move right side now with some acceleration. Yeah, tell me the acceleration of the body now. Yes, so that is A is equal to what? Tell me now. 40 minus Fk. How much the Fk value? Yes, 14 by mass.
10.
Right. So how much the acceleration? Tell me now. So 26 by 10. 40, na? So this value, how much now? 2.6 meter per second square. Right. Completed now? Yeah. So this is the manner we need to solve this type of problems. Frictional case. So for this thing, friction, you need to have some little imagination is required. You have to imagine some physical situation. Then you will understand problem. You can able to solve the problem carefully. Easy only friction concept, that is extension. Extension to the Newton's laws. Exactly. Right. Take the next one. Take it. Next one. Find the value of frictional force and acceleration. Right here, they applied certain force, 100 newtons applied vertically also. Vertically down they applied. In addition to the weight not given. Weight they don't mention. In addition to the weight, 100 newtons is also additional force we applied. So here vertically we applied one force, and here also in this case also we applied some force. Same force they applied. They can apply in here. So we need to identify how we can say directly. So that means now here this force we applied, and but here we applied like this. Will it won't move. So it won't happen. So you have to check it now. So let's see this thing, what will happen. So here the same force, when it will be at rest now. In this direction we applied, then it is rest. But one force is here, one force is here, na. Then how it is at rest? When the body is at rest, if the forces, equal forces applied in opposite direction, if the net force is 0, 100 newtons positive x, negative x we apply, then it will be 0. In this case, non-zero. One is x, one is y, na. Yeah, tell me in this case, first, we need to find the normal reaction. Yeah, tell me the normal reaction here. So we have the body, right? So this is 10 kg. Now weight, which will be 100 newtons. Right, so the normal reaction, upward direction. In addition to that, what happens now here? One more force is applied now downward direction. 100 newtons is applied, one more force. Now you tell me now here. How much the normal reaction? Body is not moving up or down. So that means net force must be 0. So that is what I can say now. N value how much? N value which is equal to 200 newtons. So this is a normal reaction. We got it as a 200. Now, and we'll find the limiting friction. Limiting friction is how much, you tell me now? That is mu s into n. So that is limiting friction, mu s value how much given? So that is 0.2 into n value how much? 200. So that is limiting friction how much now? 40. Limiting friction 40 newtons. How much the force we applied force? Applied force is how much? 100 newtons. Applied force is 100 newtons. You tell me in this case what happens now here? Applied force is more than the limiting friction, which is greater, yeah. Limiting friction is how much? Limiting friction 40. Applied force is how much? Which is greater. Applied force is greater, limiting friction is greater. Applied force is greater than the limiting friction. Applied force which is greater than the limiting friction. So what happened to the body? Rest are moving. A body is in motion. So that means it have acceleration. So it has a kinetic friction now. How much the kinetic friction now? Which is equal to mu k into n. Since the body is in motion, kinetic friction. So that is Fk, which is equal to mu k value, how much now? 0.1 into n value, how much you tell me now? 200. That is Fk value, which is equal to how much now? 20. So this is the frictional force now. Now we need to find the acceleration now. So acceleration we should find. Now we applied the 100 newtons of force is applied force and the opposing force is Fk. Now this body moves this direction now with some acceleration. So how much is acceleration you tell me now? That is 100 minus 20 by 10. So how much is value? Which is equal to 80 na? 8. 8 meter per second square. If the body is at rest, it won't be. So when the body is at rest now, yes, now here 100 newtons, we apply in the opposite direction. One is positive x, other one is negative x. And one is x, one is y. We cannot say the body is at rest or motion. Right. Yes, this we did already. Now take this. Earlier we can say now, here pulling, now it is a pushing. And which one is it pulling or pushing? Which one? What we expect now here, pushing is easy, but it won't be. You can check it. Here you will get to know that point also. Exactly same thing. We have to resolve. We need to find the n value and find the mu value. Mu value given now. We should find limiting friction. We need to check how much the applied force. N value? No. It won't be always remember. So friction, the force is there now. We have to resolve it. Never take the n value mg directly. If you do that means that is definitely mistake only. Keep in mind. N is never B, T is. If there is no force acting, then only it will be a n value equal to mg. There There is some other forces also acting on the body. So that's why you should redraw the diagram and resolve it. So weight of the body. Tell me now here, downward direction, how much is value? That is 100 newtons. And the normal reaction, upward direction. And next, what else now here? This is, we can consider this as x-axis. We applied some force is applied like this now. And this is the force. How much they given now? This is 100 newtons is given. And they given which angle given now? X-axis angle or y-axis angle? So where the angle given now? This is what axis here? This is x-axis angle means this angle only na. This angle given as 37. Now resolve it now here. So this is how much now? And this is 100 cos 37. Next, what else now? This is 100 sin 37. Now you tell me now, body is not moving up or down. That means what? Tell me now. Upward force equal to downward force. That means how much the n value? Tell me now. N is equal to 100 plus 100 sin 37. So that is n value how much now here? 100 plus 100 sin 37 value. 3 by 5. So this n value will come to be 100 plus 60, 160. This is the normal reaction. Then from this we can get the limiting friction. Find the limiting friction now. Limiting friction. How much the limiting friction is a? That is mu s into n. Yes, so how much is value? 0.3 into 160. How much is value? Limiting friction 48 na. So this is the limiting friction. Now, how much the applied force? How much the applied force? How much the applied force here? 100 cos 37. How much this value cos 37 means? So applied force which is equal to how much now here? 100 into cos 37 na? Yes, cos 37 value how much? So this is 4 by 5. So that means how much this value? Tell me now. 80 newtons. Now you tell me now which is greater? Applied force is greater than the limiting friction. The body rest at motion. Yeah, if the body is at motion, that means what type of friction? Kinetic friction. Here the applied force which is greater than the limiting friction. So that means body is in motion. If the body is in motion, tell me now, what type of friction it is a? Kinetic friction. So how much the kinetic friction you tell me now here? That is mu k into n. So that means how much the mu k value? How much? 0.2. N value? 160. So that is how much the Fk frictional force now? Which will be 32 newtons. Now we need to find the acceleration of the body also. Acceleration. So this is the applied force. How much the applied force is a? 80 newtons. Frictional force is a? So this is Fk. then the body moves this direction now. So then how much the acceleration of a body, tell me now. So this is 80 minus Fk, 32 by mass, 10 kg. How much this acceleration? Yeah, 4.8 meter per second square. Right. Understood. We should not take the n value as always simply mg. That is very crucial thing. Remember, don't take. We need to calculate based upon the figure. It will changes. Right. See this thing previously also. So in this case also, yeah, n is not equal to mg always. In this case also, n is not equal to mg. Remember. Done. Fine.